If you don't understand research, you will always depend on someone else's opinion. Every clinical guideline, every public health recommendation, every drug approval, every screening program is based on research evidence. For example, the recommendation to use statins for the cardiovascular prevention comes from the randomization control trial. The COVID-19 vaccination policies came from the phase 3 trials and observation safety data. Even the blood pressure targets we use are based on large comparative studies. Research shapes decisions that affect millions of lives. But here is the uncomfortable reality. Many people cite research without understanding how that evidence was produced. They read the conclusion, they rarely examine the methods, they trust the p-value, they don't evaluate the study design. Let me ask you something. Have you ever skipped directly to the abstract conclusion? Have you assumed statistically significant means the clinically important? Have you seen two meta-analyses reach different conclusions and wondered why? That gap is not about intelligence, it is about the training. Real power in medicine, in policy and innovation comes from understanding how knowledge is constructed. What is bias? What is confounding? Why does randomization matter? Why can observational studies overestimate the treatment effects? History gives us example. Hormone replacement therapy was once widely recommended to prevent the cardiovascular disease based on observational data. Later, randomized trials showed increased risk in the certain populations. The difference was not intention, the difference was methodology. Early studies suggest that certain anti-arrhythmic drugs suggested abnormal heart rhythms, but when tested in randomized trials, mortality increased. Observations suggest benefited, but controlled testing revealed harm. Research is not just information. Research is structure. It is the study design, control groups, randomization, blinding, systematic synthesis. Each method exists to reduce error, to reduce bias, to prevent us from being misled by the patterns that are not truly causal. I did not begin as a statistician. I did not begin as a professional writer, but I realized something. If I want to think independently, if I want to evaluate claims critically, if I want to contribute meaningful to science, I must understand the research from its foundation. So I started learning epidemiologic principles, measurements of association, causal inference frameworks, systematic reviews, meta-analysis synthesis, how data can mislead when poorly interpreted. And I realized something important. Research is not mysterious. It is disciplined thinking applied systematically. This channel, this journey is about breaking research down from foundation concept to advanced synthesis. No unnecessary complexity, no decorative jargon, just structure, clarity, methods. Because the moment you understand the research, you stop being influenced by the headlines alone. You start asking what's the design, was there any confounding, was the effect clinically meaningful. You stop being impressed by the statistical significance alone. You ask about the effect size, confidence intervals, external validity, and you begin asking better questions. And the better questions lead to the better science. This is the beginning of the structured journey from fundamentals to advanced evidence synthesis. Welcome to Thinking Independently. Thank you.